world scenario. So genetics are something that is sort of like a blueprint for what you might be able to become. I, let's say, had genes to be 6 feet tall, but something happened in my lifetime and I never made it that far. That's the difference between what we call a genotype, which is what genes you inherit, and the phenotype, which is the expression of that genetic signature into a real body. And so understanding the way humans grow and develop, but also the way nutrition and the environment affects our growth and development, is another aspect of physical anthropology. So let's just start to tackle some of these subjects head on, right? So we've looked at what physical anthropology is and what physical anthropologists try to do. And we're humans. We're interested in understanding humans. So what is a human? How does a physical anthropologist point at this creature and say that is a human and not a horse or a cow or a bird or a lizard? What are the features that we can say, okay, I know that this is a human? And this may seem a little bit pedantic, but this is the way science works. We have to be very clear about our definitions, especially when we're talking about before humans existed. When can we identify when humans arrived on the scene? When were humans around with the dinosaurs? No, they were not. So what happened? When did mammals start to arise? And when did primates? Where did primates come from? If we're primates, when are the first primates? And when did we start to split from other branches of primates? So physical anthropologists like to have some things that no other creature on Earth has as a set, a complex of factors of things that make us different from other creatures. And your book has these listed as the 6 steps to humanness. And some of the things that make us different from other animals. Now, there are other animals that do some of the things that I'm going to list here in these 6 different steps. But as a package, we're the only ones that have them. And this is partly sort of looking at the present to look at the past. We have certain things that make us different from other animals. And when you start looking at our evolutionary history, what we want to be able to do is say, aha, this creature has something that's similar to us, which means it might very well be one of our ancestors. The first of these is bipedalism. About 6 million years ago, creatures, our ancestors, or maybe even our competitors, started to walk on 2 legs. This is one of the earliest things in our evolutionary history. Another factor, which may seem a little bit obscure, but it's going to become clear to you in this course why this is such an important feature, that is to say, non-honing canines, non-honing chewing. My third tooth over on both sides is my canine. You have them too. All humans have them. They're your fangs, but they're not big pointy fangs like a vampire. But if you look at a gorilla or a chimpanzee, they have really big fangs. And actually, they grow throughout their lifetime. And they fit into a little slot in their lower part of their mouth. Those teeth slot into a sharpener. Just like you sharpen a knife, they hone. And so we don't have that. When did we lose that feature? This may seem like something that's a little bit sort of superficial, but actually it's extremely important because your teeth are intricately related to your diet. And so we have a different diet than other primates, and that is related to our evolutionary history. And so seeing when our diet started to change can tell us a little bit about when we started to have a different approach to survival than our closest relatives did. The remaining 4 steps to humanness all relate to our brain. And in increasing reliance upon using our brain for survival. The third one that's listed, from about 2.6 million years ago, is complex material culture and tool use. Now, we're not the only creatures in the world to use tools, but as you can look around you, our whole world is created by tools. We don't live in a natural environment anymore. We live in an artificially constructed environment. Our tools have come to dominate our existence. So, although we're not the only creatures, beavers, pigs, birds, chimpanzees, lots of creatures use tools. We're the only ones that actually have such a reliance upon them that it's crucial to our survival. And these tool uses, the use of these tools starts to increase in importance in our evolutionary history, such that our changing diet and our reliance on using our brains to craft things to help us to survive led to things like cooperative hunting, working together to get a really good, rich source of food through hunting animals. And of course, if you want to cooperate, you really ought to be able to communicate. Almost every creature out there has some form of communication with other creatures of its kind, but we have extremely complex speech and communication patterns, which is a whole separate sub-branch of anthropology called linguistic anthropology. But about 2 million years ago, we started to probably have spoken speech, or some kind of communication that helped us to organize ourselves and work in cooperative groups. And then about 10,000 years ago, we started to manipulate the environment and step in for biology's exclusive role in natural selection. We started to artificially select plants and animals that we thought were better for us. As we're going to see, there were some unforeseen consequences that domestication brought about, and natural selection is still working on us, and evolution is still working on us. But we started to craft an entire world around us that meant that we were changing nature to make it suit us. We're going to look at each one of these in more detail as we go on. But as you can see, those last four factors are less biological and more about our brain size and intelligence, the establishment of our culture. And so we have to think about how biology is passing on traits, but also so is our culture. Our culture is finding the routes to survival that work best, and we are passing those cultural traits down, just like we pass genes down from generation to generation biologically. So how do we know all of this stuff? And I think I mentioned in the introduction lecture that you should challenge me, and feel free to do that, because that's the way science works. Most of the facts that are in this book, you're just going to have to assume are accurate, and they are. But at the same time, these facts are things that you need to constantly recycle in your brain and say, okay, make an observation, and then you come up with a hypothesis about it. Now, the word theory is a word that we throw around in common parlance and common speaking as a guess, right? If you were just talking to your friends and you said, I've got a theory about such and such, that means a guess. But in science, theory does not mean a guess. Theory is like a scaffolding. It's the highest form of explanatory thinking that exists. It's even more important than a law in science. Laws fit into theories. You have many laws within a theory. A theory is a framework for understanding the world. And once it's established, its explanatory value is something that we constantly are attacking through testing. So when we come to talk about, in the next chapter, the theory of evolution, this doesn't not mean the guess of evolution. Evolution is a fact. Evolution is something that we can observe in real time, we can test it, and it is actually an explanatory framework. And within that explanatory framework, you can make guesses. This is what we call hypotheses. You make an observation, you say, I think that this is the case. Here is what I think reality to be. And it has to be put forward in a predictive sense where you can test it. If this hypothesis, if my guess is correct, then we would expect to see this happen in this test. If then, and then if you have either a yes or a no. If you can't say no to something, this is called the null hypothesis. If you can't nullify or falsify something, then it's not science. And this addresses one of the basic things that this course is really trying to get at, is scientific way of knowing things. We'll look at this a little bit more carefully next class, but you have to be able to reject your hypothesis for it to be science. That's the way it works. So it's a question-driven, evidence-based understanding of the natural world. So you go out, you make observations, and you test your hypotheses about them. But the theory of evolution is not just a hypothesis. It's not just a guess. It is the way that the world works. It's as robust as Newtonian physics. It's as robust as the fact that you can reliably pick up your cell phone and know where you are, and you can make phone calls on cell towers, and you can rely on that, right? You don't have to worry that, wait a minute, maybe Newtonian physics doesn't work. It's just a theory, right? No. Newtonian physics is the way the world operates. Does that mean we know everything about it? No. We still do science to try and refine our understanding of it. But Newtonian physics is the way the world works. Likewise, evolutionary theory is a framework for the way biological systems work. We can observe it and we can test it, but it is a fact. It is a scientific fact. To give you one example of how this works, Charles Darwin is often cited as being the sort of founding father of evolutionary theory. And we're going to look at that and scrutinize that a little bit, because he didn't invent evolution. He just made some of the earliest definitions of the way that worked. He identified the way the world worked in the same way that Newton saw that gravity was working, right? Newton didn't invent gravity, just the same way that Charles Darwin didn't invent evolution. It's a great example of the way the scientific method works. For instance, Charles Darwin looked at, he was interested in paleoanthropology. He was interested in human evolution as well as evolution of other creatures. And we'll look at him a little bit more carefully next chapter. And Charles Darwin didn't have evidence to test the theories of human evolution because there had been really no excavations of human ancestor fossils at that point. He didn't have the data. He didn't have the means to test his hypotheses. That didn't mean he didn't make hypotheses, his guesses within the framework, and he supposed that one day we would have the evidence to be able to test it. And just to show you that Charles Darwin was not some sort of a god, and he wasn't just inventing things out of his brain, he had the hypothesis of why humans stood on two legs. And he proposed it as an if-then hypothesis. He said that his hypothesis was that humans started to walk on two legs because we started to use tools. He said that having your hands free allows you to use tools, and that was important for our survival. But he had no evidence to test that. we now know that Charles Darwin, in this hypothesis, not in his theory of evolution, but in this hypothesis about why humans stood on two legs, is false. He was wrong about that, and he would be perfectly happy about that, because that's the way science works, and he was a scientist. And the reason why we know that that hypothesis is wrong is because if tool use was in the factor as to why we started standing on two legs, to free up our hands to use our tools, then, if that's the case, then you would expect to see tool use coming before people walked on two legs. He had some other elements to this where he thought that there was climate change and people started to move out onto the savannah. All of these things he had no evidence for, but he made a hypothesis. Now that we're able to test that hypothesis, we see that actually the first thing was people started to walk on two legs. And only millions of years later, something like 4 million years later, that's when tool use started to come about. So his hypothesis about the reasons why we're bipedal has been falsified. There's another explanation. It still works within the framework of evolution, but we have to come up with another explanation. So Charles Darwin is able to be falsified. His hypotheses are able to be falsified. And I'm not going to use the word Darwinism, because Darwinism is just evolution. And evolution is a theory that we all can get behind. It has nothing to do about the man, although we're going to see that he was actually sort of the right person at the right time in the right place. So I want you to apply your scientific thinking to these questions as we come to them. And we'll turn our attention next class to the history of the discipline and how evolution as a concept started to come about, and who some of the names in the background to that process were. See you then.